everyone, welcome back to the channel. So today in this video lecture we're going to be solving this problem, shortest path in binary matrix. So this problem is also included in the Dijkstra algorithm problems list, although this can be solved using a simple graph traversal algorithm like breadth first search, but we'll solve this using Dijkstra algorithm because it is there in the list. So let's read the problem statement. We're given an n cross n binary matrix, means we have a matrix containing zeros and ones only. We have to return the length of the shortest clear path in the matrix. If there is no clear path, then return -1. So what is a clear path in a binary matrix? It is a path from the top left cell, that is 0 0, to the bottom right cell, that is n minus 1 n minus 1, because the dimensions of the matrix is n cross n. Fine. So such that the clear path, all the visited cells of the path are 0, all like the cells which I am visiting along the path, they must contain 0 only, and all the adjacent cells of the path are 8 directionally connected. Okay, means all of the cells are different and they share an edge or a corner. So the length of a clear path is the number of visited cells of this path. So let's better understand the problem statement using an example. So let's take this example. We have a matrix of dimensions 3 cross 3. So we always have a square matrix, remember. Now this, we have to start from this cell 0 0 and we want to end at this cell, that is 2 2. Okay, here. Now the shortest clear path would be this one, that is move from the cell 0 0 to 0 1, then from cell 0 1 to 1 2, then finally from cell 1 2 to the cell 2 2 here. Okay, we have to visit 1 2 3 4 cells, and 4 is the answer for this test case. Why? Because we are given that from any given cell I can move to 8 directions: left, right, up, down, along the corners as well. Fine. Like from here I can move to this cell, I can move to left cell, I can move to the cell below it, I can move to the cell just above it, I can move to this cell, I can move to this cell, to this cell, as well as to this cell. So these are the directions which we are allowed to move. Therefore this is the shortest path that we can have, starting from the cell 0 0 till the cell 2 2. That is, move from the first cell 0 0 to 0 1, then from 0 1 to 1 2, then from 1 2 to 2 2. Fine. So that's all. How can I solve this problem? We can see that if you have watched the previous video, you will easily get the idea that this is a single source shortest path problem. The only difference here is that we have, whenever we are visiting a adjacent cell or the neighbor cell, we have to check if there is a 0. Also, the number of options for the neighbor cells increases from 4 to 8, because for every cell we have maximum 8 cells as the adjacent cells. Rest remains the same. We just have to perform the usual Dijkstra algorithm, that is, just push the very first cell along with its distance in a priority queue and just run the Dijkstra algorithm. So let's see that how we can do that. So we simply take a priority queue, we push the cell 0 0 in this priority queue along with its distance, that would be 0. Okay. Now from this cell we traverse. Now we have this. Now we run the while loop and we pop this only tuple from the priority queue. So we pop 0 0 0. Now from this cell 0 0 I can move to cell 0 1. Can I move to cell 1 0? No, I can't. I cannot move to this cell. So the only option is this, that I can move to cell 0 1. So just move to the cell 0 1 and push it into the priority queue. Also, as we usually do, we also have to keep a distance array. So we keep a distance array. So in this distance array, for the very first cell I put 0 because the distance for the source cell is 0. Then okay, so we have to initialize this distance array with a very large number. So this is initialized with infinity, inf, or let's say a very large number, 1e9, something like this. Now from this cell 0 0 I can move to cell 0 1. So move to cell 0 1 and push the pair corresponding to it, while the cost will increase by 1. Okay, so the cost will be 1 here. 1 is better than the cost which we already had, that is 1e9, so we update the cost here. Now again in the very next iteration I pull out this only tuple which we have in the priority queue corresponding to this cell 0 1. So this is cell 0 1. Now from this cell 0 1 I can move to cell 0 2 and I can move to cell 1 2 because these are only valid cells that we have. All other cells are invalid because this cell contains 1 and we have already visited this cell 0 0. So we already have the best cost for cell 0 0. So the remaining cells are cell 0 2 and cell 1 2. So we update the cost array or the distance array for these cells, that is for 0 2. For 0 2 we'll update it to this, the parent cell is this, which is 0 1. So for 0 1 we have 1, so it would be 1 plus 1, that is 2. 2 steps to move to cell 0 2, also 2 steps to move to cell 1 2. Okay, so we can also represent it like this. So we had 0 0, we moved to cell 0 1 with a cost of 1 unit. Then from 0 1 we moved to cell 0 2 and to cell 1 2 with the costs of 1 and 1 unit. So to reach these cells the costs are 2 units, and we also push these cells into the priority queue. So we have 0 2 with a cost of 2 units, also 1 2 with a cost of 2 units. Fine, so this was out. Now out of these two cells, let's say I pull this cell, that is 0 2. Now this is out. Now from cell 0 2 I can move to cell 1 2 and I can move, that's all. I can just move to cell 1 2. So I just move to cell 1 2, but the cost would be, so from 0 2 I can move to cell 1 2 here with the cost of 1 unit. So that is going to give me 2 for the cell 0 2, and to move to cell 1 2 we would have 1 2, we would have 3 units. But we can see that here we already have a better answer. We have 2 units. We have reached the cell 1 2 with 2 units, or by visiting 2 cells. Okay, that means we will discard this distance that we have. We'll discard the distance that is 3, which I calculate while moving from cell 0 2 to cell 1 2. Now let's pick this tuple, that is 2 1 2 for cell 1 2. Now from cell 1 2 I can move to only this cell, that is 2 2, because this is the only valid cell that we have. So I move to 2 2 with the cost of, so from 1 2 I move to cell 2 2 and the cost to move will be 3. Fine, because it takes 1 unit of cost to move to the adjacent cell, and this is my destination cell. I can see that. So I arrive the destination cell here. Okay, that means how many cells I have visited? Actual cells are visited are 1 2 3 4, and here we have 3 stored. This is because we initialized here, we initialized this cell the cost array for cell 0 0 with 0. If I have initialized this with 1, then the answer that we have got for here would have been 4. So we simply return the answer that we have here, that is 3 plus 1. That represents my number of cells that I have visited, the valid cells that I have visited, starting from cell 0 0 till cell 2 2, this along this path. Okay, so the answer is 4. So that's how we solve this problem, the standard Dijkstra algorithm. So let's just implement it. If you have watched the previous video, then you would easily figure out the problem. So let's code it up. Okay, so this is the shortest path binary matrix function. It takes in this grid. Okay, so it takes in this grid, and now I will simply, so I calculate the dimensions of this grid. So this is a square matrix. So we will have a n cross n matrix. Now I declare a priority queue of vector push the very first cell into the priority queue. The very first cell is 0 0 here, 0 0, while its distance is 0. So let's say the distance is 1. So also we have to handle base cases, like think about the cases when we have a grid like this, a grid containing only one cell, and that cell contains 1. So if this is the case, that is n is equals to 1, then if the only cell that we have in the grid, if this contains 1, then that means it is not possible. Then in that case I will return -1. Otherwise, if this contains 0, then the answer would be 1, because the source and destination cells are same, and we have to visit exactly one cell to reach from the source to destination. Okay, this is basically the base case. Okay, so also think about another base case. Think about the case when we have like things like when the starting cell 0 0 or the ending cell n-1 n-1 contains 1. Any of the cells contains 1, either cell 0 0 or cell n-1 n-1 contains 0, contains 1. In that case, I will never be able to get a valid path. So in that case, I will return, so if grid 0 0 plus grid n-1 n-1 is not equal to 0, then we return -1 because there is no valid path. Fine. Also we create a distance array to store the distance, for the minimum distance for each cell. So its dimension would be n cross n, n1e9, and let's initialize it for the very first cell with 1. Now let's run the while loop. So till this priority queue is not empty, I will run this while loop and simply pop the top element from the priority queue, which will be a vector. So pq.top, okay, and just find the cost which we have here, or distance, let's call it dis, which will be the very first element in this vector top. Also the x coordinate of this cell, that would be top 1, the y coordinate, that would be top Fine. Then after that we'll have here we're going to check if the so here check if the distance that we already have for this cell xy, if it is better than the distance that we have which is associated with this tuple. In that case, just continue right from here. We don't have to update it. Otherwise, move to all 8 adjacent directions. So to move to all 8 adjacent directions, I declare 2 arrays, that is dx to move along x direction, and an array dy to move along y. Okay, so these vectors are used to move to the 8 directions of the given cell, adjacent directions, because all of the cells which shares an edge or a corner are adjacent cells. So iterate over all the 8 directions and calculate the new x, that would be x plus dxi. The new y would be y plus dyi. Now here check if this new x and new y are within the boundary of the matrix. And if this contains 0, okay, if this new cell contains 0, also we have to check if these new cells which we have, so that means these cells can be, that means the cell is a valid cell. Now here check if the distance that we calculate for this cell is better. If it is the case, then update the distance for this cell and push this new cell into the priority queue. So it's 1 plus dis new x new y. Okay, so finally, okay, I forgot to pop the element pq.pop. So here I can also check if the new cell which we have, so if this new cell new x and new y, they represent the bottom right cell. If it is the case, then just return the distance that we have calculated for these cells. Fine. Otherwise, return -1 if I never encounter the ending cell. Fine. So let's see. Let's see if it works. It's giving me wrong answer because I have to return 1 plus dis. Okay, let's see now. Yeah, it's working. Let's submit it. Okay, it got accepted. So that's all we have to do in this problem. The time and space complexity is same as the Dijkstra algorithm, which we have discussed in the previous video. So that's all for this video. I hope to see you all in my next video.